CS 3351 Digital Principles and Computer Organization. Topic is Catch Mapping Techniques, presented by Devi Visalakshi, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. Catch mapping techniques. Memory mapping is the process that associates an address value to some existing physical location in the hardware. This location can be RAM in a cache of some level or even on the hard disk. During program execution, data can move from one location to another and possibly be duplicated. Mapping function. The correspondence between the main memory blocks and those in the cache specified by a mapping function. The different cache mapping techniques are as follows. Direct mapping, associative mapping, set associative mapping. Consider a cache consisting of 128 blocks of 16 words each for total of 2048 words, and assume that the main memory is addressable by 16-bit address. Main memory is 16K, 64K, which will be viewed as 4K blocks of 16 words each. Direct mapping. This is the sample diagram for direct mapping. Here in this cache block, it's having block 0 to block 127, and the main memory it's having block 0 to block 4095. In main memory address, it's having the format of tag block word. The simplest way to determine cache locations in which store memory blocks in direct mapping technique. In this, block J of the main memory maps onto block J modulo 128 of the each. This is main memory blocks 0, 128, 256 is loaded into cache is stored at block 0. Block 1, block 129, 257 are stored at block 1 and so on. Placement of a block in the cache is determined from memory address. Memory address is divided into 3 fields. The lower 4 bits selects one of the 16 words in a block. When a new block enters the cache, the 7-bit cache block field determines the cache positions in which this block must be stored. This higher order 5 in cache. They identify which of the 32 blocks that are mapped into the cache bits of the memory address of the block are stored in 5 tag bits associated with its location, position and currently resident in a cache. Advantage: it is easy to implement. Drawbacks: since more than one memory block is mapped onto a given cache block position, contention may arise for the position even when the cache is not full. Contention is resolved by allowing the new block to override the currently resident block. This method is not very flexible. This diagram is for fully associative mapping. In this cache, it's having block 0 to block 127, as well as in main memory block 0 to block 4095. In memory, it's having the format of tag as well as VAD. This is more flexible mapping method in which main memory block can be placed into any cache block position. In this, 12 tag bits are required to identify a memory block when it is resident in the cache. The tag bits are often address received from the processor or compared to the tag bits of each block of the cache to see if the desired block is present. This is known as associative mapping technique. Set associated mapping. This is the diagram for set associated mapping. Here each set blocks are divided into the sets, and then in the main memory it's having blocks 0 to block 4095. In main memory address it's having tag, set as well as word. It is a combination of direct and associative mapping technique. Cache blocks are grouped into sets and mapping allow block of a main memory reside into any block of a specific set. Hence, contention problem of direct mapping is eased. At the same time, hardware cost is reduced by decreasing the size of the associate search. Having 64 bits means that the 6 sets field of the address determines which set of the cache might contain the desired block. This is known as two-way associative search. Advantages. The contention problem of the direct mapping is easy by having a few choices of block placement. At the same time, the hardware cost is reduced by decreasing the size of the associative search.